अकेले बैठेंगे ना यार
तुम अकेला
कुछ नहीं कर पाएंगे
टीचर सामने अरे चल टीचर आ गए
मैं फोटो बना नहीं आया प्लीज
You have a half an hour break or 15 minutes break?
15 minutes.
15 minutes.
But before there was a confusion.
10:45. You came at what?
We came
7:30, no?
Yes.
7:30, 8:30, 9:30, 10. 10 o'clock is over. Yeah?
No, it got over at 10:45. 10:45 to 11.
Or half 15 minutes break.
And then 9 o'clock to 9:50.
Did like any television? Yeah, we back here about the guys.
Arish.
Section is special.
Yeah. Vaishnavi.
Can I switch my screen on?
The same.
What about Ayush? Is he present?
No, I think so.
He was not present for the first
No, no,
section.
No, he was
He-
not enrolled for SST.
Not big.
इस पर बैठ के इधर थोड़ी बैठी है भाई इस पर बैठना
भाई तू लोग बुक खोला यार?
नहीं मुझे नहीं खोलना
Last.
पेज फाड़ दे मुझे भैया ने किया इसने लिखा है
Good morning. Next question. Good morning. Please sit down. You have the habit of revising what we have already done. Yeah, are we revising? Now, of course, there's no school, so you should actually make use of this time. Why the girls are going behind? Coming up.
cold where the AC is running
Talking.
I'm not
Okay, let's see what we have done last time. Today we'll be able to complete the chapter on electric current. It's not about children.
come on mama down
Ready? Are you ready? That's Let's quickly revise with the formulas. I want you to think of all the formulas that we have learned so far. Okay, and in the end, we will make a list so that we remember.
this one sign.
Manish did not come.
Manu was there, but he has to leave. He has gone out to leave for a wedding. So
There's no you have to sign. Shut it down. There's no need to come and sign. So yesterday we were talking about the heating effect. We have learned three formulas for heating effect. Okay. So H is equal to what?
PI,
DIT I square RT and
P square, T upon.
Yes, H is equal to, what is that? I square
RT
RT, and then H is equal to V square.
minus T
I minus
P square, T upon R.
V
square
T upon R.
Correct. V square T upon R. Okay. So even if you're finding it difficult to remember all the three formulas, there's no problem. Even if you remember one formula, you can derive the other three. Isn't it? So which formula are we using? All the time. All the time we are going to be utilizing Ohm's law. Okay. So if at all you remember VIT, it's perfectly alright. So you can substitute either V or you can substitute I by using Ohm's law. Okay, V is equal to IR. So if we remember Ohm's law, this is going to be very useful because you can substitute either for V or you can substitute for I, and then therefore you will be able to get the other two formulas. And it doesn't take much time. So don't fret over not remembering all the three. Okay. Now where do we need to remember all the three formulas? Is sometimes you find here in this particular case R is not given. Okay. Here in this particular case V is not given. And here I is not given. So we'll have to pick and choose the right type of a formula depending upon what is given in the sum. Is that okay? Right? So this is what we have done yesterday. Next, we were also talking about power. We have seen that power is equal to work upon time. Now let's take a simple example what we have learned last standard. That's regarding actually the mechanical power. Suppose you have a staircase, right? And let us say there are about 50 steps or whatever it is. Then we have two children here, A and B. Suppose B is taking 20 seconds and A is taking, let us say, 12 seconds to reach. Right? We need to reach the top of the flight. So they are going to run up the stairs. Right? Look at the time factor. A has taken 12 seconds, whereas B has taken 20 seconds. Now, my question is, who is more powerful? What will you say? A. A is more powerful. Why? He has taken less time. Because the work done is the same for both of them. Work done is the same thing. But A has taken less time. Did you understand? So whenever we talk about power, it is always in comparison to the time taken. Have you followed? Now the same concept we are going to use for electric power. Now last class we have talked about power, which is equal to V times I, isn't it? Where V happens to be the potential difference or the voltage, and I happens to be the current which is being taken by the appliance. So if we know the amount of current that has been taken by the appliance, and we also know what is the voltage, which is usually about 220 volts, we can immediately calculate our power. And what is the SI unit of power? Watt. Okay, so it is watt. Obviously, because in honor of the scientist who is James Watt, who has actually found out that power, each of these appliances has got a different power input. So now we are going to be talking about this particular formula once again. So we said power is nothing but the work done upon time. Last class I was also telling you that work and energy are interrelated. Why do we say it is interrelated? If you want to do work, you need to have energy. Okay? So that means to say, if you are doing some work, output will be definitely energy. Okay, so these two are always interrelated. And what will be the unit for work? What is the SI unit for work? Correct, I heard the word, what is it? Joule. Correct? So now we are going to talk about work and energy. So we said power is equal to work divided by time. So instead of work, I can also talk in terms of energy. Isn't it? So now suppose I want to rearrange this. I talk in terms of electrical energy. Use this formula. What will it be? P times T. Correct? Did you understand? So electrical energy is P times T. Now what is P? P is nothing, power. So it is power times the time. Correct? And we also seen that power is expressed in watt. This is the W. Don't get confused. What work is W, what is also W. But this is capital. Okay? And time is usually, we take it as seconds. But we know that any of these appliances, we are not going to be using in terms of seconds. First listen and then I'll ask you. One, don't write down trash, don't write down anything. I'll tell you how to write down. It's usually not in seconds, but it is going to be in hours. Fan is going to be moving for so many hours. Light is going to be using. Okay? So we are never going to be using seconds. So if at all we want to find out or calculate electrical energy, and even in hour, we are going to convert seconds into hours, and instead of writing it in watts, we are going to use another bigger unit, which happens to be kilowatt. Okay, times, instead of seconds, we are going to write it as hour. Are you comfortable with what I'm saying? No. Tell me, I can repeat. Did you understand? I'll rub out this part so that it is okay for you. We said power is equal to work upon time. Is that okay? I'm repeating the whole thing again. If you want, you can write down. Come on, write. Start from there. Power is equal to work upon time. Okay? But we know that work and electrical energy are interrelated. Okay? So I can also write it as power is equal to the electrical energy upon time. Therefore, if I want to write about energy, electrical energy which is drawn, it is nothing but power into time. Okay. I can say energy is P into T. Now power is usually given in watt and time is usually given in second. But these are very, very small units and it has absolutely no, it does not make any sense. Because we know that all the electrical appliances are going to work in hours. So now we are going to use a bigger unit. So what is a bigger unit? 1000 watt is equal to 1 kilowatt. Okay. And instead of writing it in seconds, I can write it as 1 hour. So we know that 60 times 60 to 60 seconds will make 1 hour. So instead of writing it as watt second, energy can also be expressed as kilowatt hour. Okay. Now what happens basically is when you get your electricity bill, have you seen your electricity bill? Sometimes your parents will say, oh, switch off the light fan. So much electricity bill is there. Okay, why? Because we are consuming electricity for various type of appliances. And in summers, we know that it is going to be pretty high, right? Our consumption is more because we have switched on the ACs in all the rooms, isn't it? So our consumption is definitely more. That is because if you look at the electricity bill, we have something called as units. Okay? There are some months that you find that your units will be slightly less. Maybe you are getting something like 220 units. Okay? Maybe I'm just talking about the units. Maybe in some months it will be very, very high. Maybe it is 875 units. Okay? In some months it may be low. In some of the months maybe it may be something else. Maybe it is 512 units. Now what are these units? And we pay our bill according to the number of units that you have consumed. Suppose your MSEB is charging you according to these units. They'll say it is at the rate of 4 rupees per unit. Do you understand? Suppose you have consumed 220 units. What is the bill that you have to pay? Times 4. How much is that? 880. Isn't it? 4 rupees per unit. And if you have consumed 220 units. So obviously you have to pay so much money. Isn't it? Okay, did you understand? Now what is this unit? Is this part? This is 1 unit. So therefore, whenever the MSEB is talking in terms of 1 unit, It means it is 1 kilowatt hour that you have used. Have you followed? So the moment you calculate your energy consumed in terms of kilowatt hour, it means that you have consumed 1 unit. So if I'm giving you as 220 units, what does it mean? You have consumed 220 kilowatt hours. Is that okay? Did you understand? So that is how it is actually calculated. I'm just giving you a small example. And this we know it is not a constant, okay, because it is obviously going to vary month to month, depending upon the consumption. It may be more in summer months, maybe in rainy season or winter months, it may be slightly less. Okay, so it's never going to be a constant. So this is an indication as to how many units you have consumed. So today what you're going to do is as soon as you go home, just look at your bill, electricity bill, you will find for the month of April, so many months have been utilized. For the month of March, how many bits or how many units have been utilized. So depending upon that, we pay our electricity bill. Is that okay? Is that okay, clear? Okay. Now we have come till here. All of you have written. So therefore, energy is expressed in kilowatt hour, right? Now we are going to see what is 1 kilowatt hour in terms of, let us say, joules. So we come to this page. Come to page number 191. Page number 191. The heading is electric power. Okay, practical applications I will do later. This part of it I will do later. Electric power, we have studied in the earlier class. Did you get that? Okay. That rate of doing work is power. Underline that. The word rate is very, very important because the rate means we are comparing it with respect to time. First line. Okay. This is also the rate of consumption of energy. Which energy are we consuming? What energy are we consuming? It is the electrical energy. Electrical energy we are taking in and then it is getting converted into different type of energies. Okay. Now equation 11.21. What is 11.21? That is P is equal to V into I. Now this gives the rate at which the electrical energy is dissipated or consumed. Did you underline the word dissipated? Means how much of electricity we are using, right, for our different appliances. This is also termed as electric power. Underline what is electric power? Okay, it is the rate at which the electrical energy is dissipated or consumed in an electric circuit. That's your definition. Did you get it? So P is equal to V into I. Right? Once again, we are substituting V by using Ohm's law, or we are using I, substituting I using Ohm's law, and therefore you are getting two other formulas. So P is equal to I square R and P is equal to V square upon R. So how did we get it? Substitute either V or substitute either I or V by using Ohm's law. The SI unit of electric power is watt, but it is capital W because it is in honor of the scientist. So it is always capital, right?
What is the name of scientist?
He is the one who actually did a lot of work on steam engines. You remember steam engines? Have you ever seen a steam engine in your life? You guys wouldn't have traveled, I think, mostly not. Because basically what happens is we are using coal. Where? Yeah, that's it. Okay. So that is, we are using coal. Coal is used to heat up water. Water is getting converted into steam. And it is the steam which is moving the piston. Okay, so that is how the wheels are moving ahead. Yes, I think it is still, some pockets we are still at. But no, most of the trains have now got converted into electric trains. So that is basically, he was the one who performed, who realized that it was steam which is capable of, actually there's a small story. As a child, I believe he was a dropout from school. Okay, so he used to spend half the time at home only doing various things. So one day his mother was boiling in a kettle some water. Okay, and the lid was kept on the vessel. So when the water was boiling, obviously it turned into steam, and the vessels, the lid on the top of the vessel kept on popping up and up. So that's when he started thinking that what is actually pushing it up. And that we realized that it was the steam which is capable of pushing the lid up. So that means it can have enough energy, to do some kind of a work. So that is how we came up with the concept of utilizing steam in order to drive an engine. See from where to where, and just imagine it was basically a school dropout. So he has done a lot of work, lot of work on based on this type of work. So it is James Watt. Okay, right. Now, it is the power consumed by a device that carries. What's the time, Beta?
I might not know the distance.
Somebody had to call you. Huh? Okay, that carries 1 amp of current when operated at a potential difference of 1 V. Do you see that? 1 V. It is not 5. It's not Roman number 5, it is V. What does that V stands for? Volt. So 1 W, that is 1 watt, is equal to 1 volt times 1 ampere. Okay. So it is 1 VA. Okay, it's not Roman number 5. The unit watt is very small. Therefore, in actual practice, we use a much larger unit called as kilowatt. Underline the word kilowatt, which is equal to 1000 watt. How do you remember? The word kilo. Anytime that you are using kilo is 1000. Since electrical energy is a product of power and time. See what have we written? Electrical energy is a product of power and time. Underline that statement. And also write down the formula there. E is equal to electrical energy is equal to P into T. The unit of electrical energy is therefore watt hour. So watt and time, instead of writing seconds, it is hour. Okay. Similarly, watt, we are using a bigger unit which is 1 kilowatt, and therefore we are talking in terms of 1 kilowatt hour. The commercial unit, the last line there, the commercial unit of electrical energy is kilowatt hour. So this is your kilowatt hour. Why are we talking about commercial unit? Because commercially, either in an industry or for domestic supplies, this is the unit that we will be using, kilowatt hour. Are we clear about it? Now this paragraph is very, very important. There's a lot of questions that we can ask for your MCQ. You have to be very thorough with it. Okay. Now the next part of it is they have given you a small conversion. Till where have you written? Have you written till here, children? Have you written till here? Okay. So 1 kilowatt hour is equal to 1 unit. This is what I want you to understand, that it is equal to 1 unit. And this 1 unit is the one that is usually given in your electricity bills. Is that okay? Now we want to find out how much is this 1 kilowatt hour. 1 kilowatt hour in terms of joule. Okay. Let's look at this. Kilowatt. How many kilowatt? It is equal to 1000 watts. Correct? And when we are talking about an hour, basically it means 60 times 60 seconds. Okay. So how much is that? How many zeros? So 1, 2, 3, 4 and 5. So it's 10 raised to the power of 5. And you have got 6 and 6. That is 36. And what are the units? That is equal to watt second. Or you can also write it as shift tab decimal place 3.6 into 10 raised to the power of 6. Instead of writing watt second, you can also write it as joule. Is that okay? Take it down. Got it? Try to memorize it now only. Memorize it. It's very easy. Only thing is stepwise you're going to be talking. Is that okay? Now look at this point. We said that energy is equal to power into time. Is everybody okay with that? So I'm putting it as energy is equal to P times T. Okay. In your school timetable, you have a PT period. What does the PT stand for? Huh? Play. Playing, not playing tech.
Basic
Physical.
physical education.
Okay. Training. Basically, it's physical training. But then, of course, it is getting. Okay. So it gets translated as a free period and you can jump and enjoy. Fine. But then you require a lot of energy to do that. So how will you remember this equation? You require energy for PT periods. Easy for you to remember, okay? Just as I told you about quit India movement. Q is equal to IT. So similarly, some simple silly things I'm telling you in the class just for it to make it easier for you to remember. How do you get your energy? For playing in PT periods, you need to have energy. So electrical energy is power into time. Will you remember that? Okay, fine. So this is what we will be talking about in the next part of the lesson. That means we have already spoken about the heating effect, and as a result of heating effect, we are also talking about what could be the power of various type of appliances and how much of electricity is drawn. Okay, so we are going to be seeing that. Before we go on to a couple of sums, come to the previous page, practical applications of the heating effect. Last class I was telling you about an electric bulb, isn't it? So what type of a bulb is that? That is an incandescent bulb, right? Because when you switch on, obviously it is going to glow, correct? So what type of energy is being supplied? We are talking about conversion of energy. What is energy supplied? Electrical energy is supplied. What is it getting converted into? Heat energy. Yes, it's getting converted into heat energy. And a small part of it is also getting converted into light energy. Okay. Sometimes the questions asked is very simple. They may say in an incandescent bulb, right? What are the energy conversions? Energy conversion. Do you understand the word? Okay. So energy conversion, you have to start by saying that electrical energy is getting converted into. Okay. And what type of a bulb is this? Electric bulb is also called as an incandescent bulb. Basically, you're heating up the element, and because of the heat which is supplied, part of it is also light. What type of material are we using? Is it a good conductor? Is it an insulator? Or is it another? It has to be a good conductor, but at the same time, it also has to get heated up. So, what substance have we used here? Tungsten. We are using tungsten. I told you yesterday because it has got a very, very high melting point, almost about 3080 degrees Celsius, so that it doesn't melt. Okay, and also we have seen that this bulb, air has to be taken out because we have to prevent oxidation. Oxygen should not be there in the bulb to prevent oxidation. So what are we doing? Taking out air, and we are putting either inert gases or even nitrogen, which is pretty inert. Okay, did you understand? Okay, let's read the first paragraph. Now when you are reading, I expect everybody to underline a few lines, few important terms. The generation of heat in a conductor is an inevitable consequence of electric current. What does it mean? I'm stopping after every sentence and asking you, what does it mean?
Like it is an application of electric current.
Okay, so it is an inevitable consequence. Means what? Inevitably it is going to happen. Okay, so that's why we are trying to use different type of substances. Can we use tungsten for these wires? No. What do we use? Aluminum or copper. Very good. Yes. Can we use silver or gold?
Yes, we can.
But are we using?
No.
Why?
So it's expensive.
Expensive. So we have to keep all these things in mind. It should be a good conductor. It should not be expensive, but at the the same time, it should not get heated and therefore it should be, So now what do we want?
Silver.
Silver, not much, because it's a very good conductor. Electricity will flow through very easily. Okay? But gold and silver are definitely used in your electrical company, in your mobile phones, electrical circuits, in the computers, and that's why the cost of such type of electronic goods is very high. Do you understand? Very small micro circuits are present there, which are basically using silver and gold. Okay, so that's why the cost is very high. And that's why we say that when we want to buy a new mobile phone, dispose it of properly. Because the resale value is also there, they can extract all these metals. Okay, now, in many cases, it is undesirable as it converts useful electrical energy into heat. You remember from the dam, I'm going back to the production of electricity. From where is it produced? Dam, hydroelectric power stations. From there, the big wires are coming to the, especially when you're traveling from state to state or something, or that's by train or buses, you find those big wires, no? So they are the ones which is power transmission. Okay. So what type of wires are they? Thin wires? Thick wires. The greater the cross-sectional area, the lesser is the resistance. So there's no resistance, and therefore those wires don't get heated. Do you understand? Now why it is happening? Why do we use thin wires as in this case? Why do we use a thin wires? Because we want a higher resistance. So think in those lines, okay? In electric circuits, the unavoidable heating can increase the temperature of the components and alter their properties. Read, somebody please. Read slowly. After every sentence, we have to think and answer.
However, heating effect of electric current has many useful applications. The electric laundry iron, electric toaster, electric oven, electric kettle, and electric heater are some of the familiar devices based on Joule's heating. The electric heating is also used to produce light, as in an electric bulb. Here, the filament must retain as much of the heat generated as is possible, so that it gets very hot and emits light.
Stop. It gets very hot and emits light. Those two words are not used. So that's why it is called what type of a bulb? Incandescent bulb. That means where light is produced because of a hot filament. Okay.
It must not melt at such high temperature. A strong metal with high melting point, such as tungsten, melting point 3380 degrees Celsius,
Underline that.
is used for making bulb filaments, the insulating support, etc. The filament should be thermally isolated as much as possible using insulating support, etc. The bulbs are usually filled with chemically inactive nitrogen and argon gases to prolong the life of filament.
So how can we prolong the life of a filament? Inactive nitrogen. Okay. Nitrogen obviously does not bring about oxidation or any other thing, right?
How the bulb is thermally actually.
Where
Thermally, the filament should be thermally.
there's a ceramic thing on the top. If you actually see hold the bulb in your hand and see, this part of it is glass, and then there's a top thing on the top which is ceramic. So ceramic tiles are supposed to be thermally insulated. In fact, your Apollo 13 and all that, when the rockets go into space, okay, so all this surrounded by means of the atmosphere, right? It is going into space, but the moment it comes back again into space is the most difficult part. Why? Because it causes a lot of friction. Just coming, yes, not only that, coming back again into the earth causes a lot of friction and the entire spacecraft is going to heat up. Okay, it can melt. So in order to prevent that, the outer part of the aircraft is usually fitted with those tiny ceramic tiles. Do you understand? So specially manufactured ceramic is basically heat insulated.
Most of the power consumed by the filament appears as heat, but a small part of it is in the form of light radiating.
Did you understand what are the points that we are going to be talking about? I think there is a question which is given behind regarding the body. Question number 18.
18.
18. Wise tungsten used almost exclusively for filament of electric lamps.
It has
No,
high
And melting point which should retain heat, okay, and also bring about the conversion from heat energy to light energy. All those 3 points. Put a tick mark and you know this 18A. Okay, come back.
Another common application of Joule's heating is the fuse used in electrical circuits. It protects circuits and appliances by stopping the flow of any unduly high electric current. The fuse is placed in series with the device. It consists of a piece of wire made of metal or an alloy of appropriate melting point. For example, aluminium, copper, iron, lead, etc. If a current larger than the specified value flows through the circuit, the temperature of the fuse wires decreases. This melts the fuse wire and breaks the circuit. The fuse wire is usually encased in a cartridge of propylene or
Porcelain.
similar
Porcelain.
porcelain or similar material.
You have seen porcelain, you know, beds, vase and other things, no? That's porcelain is a type of a glass which is once again heat resistant.
Porcelain or similar material with metal ends. The fuse is used for domestic purposes are rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere, 8 ampere, 10 ampere, etc. For an electric iron which consumes 1 kilowatt electric power when operated at 220 volt, current of 1000 by 220 A ampere, that is 4.54 ampere will flow in the current. In this case, a 5 ampere fuse must be used.
Okay. So one part of it is we have spoken about. First thing is we have spoken about the bulb. Here it is the heating agent. The second application that we are going to be talking about is the fuse. Do you know why fuse is used? Have you heard about fuse? Yeah? Okay. So let's say this is your household and electricity is being supplied to it by obviously the mains, right? Doesn't directly come to the house, it has to go through the fuse. So let us say this is the fuse. Now basically it is a very small device and it has got a small wire here. This is your fuse wire. Okay. And this has got a low melting point. Basically it's made up of either an alloy or even a metal which has got a very low melting point. Let's see what is happening. Sometimes there is a power outage. Right? There may be a surge of current or whatever it is. So what happens is too much current will flow into the house. Maybe it can also destroy your TV or your computer or whatever it is. Suppose we don't want that to happen. Is obviously we are using a fuse wire as a protection or to prevent any major damage. So what happens is there's an excess amount of current. This fuse wire, because it has got a low melting point, that gets heated up. Okay, so when that gets heated up, imagine that this is the wire which is here inside. This is getting melted. Okay, at that temperature, this will melt. So what will happen immediately? This current will stop.
That's why we say fuse will be
Fuse would, yeah, and luckily your household gadgets are saved. Have you all followed what is happening? So this is nothing but a safety device in order to save or prevent any type of undue damage to the household appliances. Okay, earlier days we used to have this fuse wire and then fuse would here, then you have to take it out and put another wire there and fix it back again. Okay, now of course we are having circuit breakers, MCBs. Okay, so there's a micro circuit breakers which is usually put there and it trips. Have you seen it tripping down? It trips down if there is an excessive, power outage or whatever it is. Correct? Now, look at the last few lines there. They have given you 1 amp, 2 amp, 5 amp, etc., etc. For example, we have already discussed that appliances in the home always should be connected in series or is it in parallel? Remember yesterday's? Yes, it is going to be in parallel. Okay. So for each of these gadgets, there is a different fuse, right? So if there is a gadget which is drawing in too much of a power, obviously you have to have a special kind of the fuse wire. Take down this and we'll also do that little sum. Take down now. Till here, have you finished what is the last thing that you have written in terms of joule and all that? Okay, 3.6 into 10 raised to power of 6. Okay, so that is equal to 1 kilowatt hour. Right. Next, write down heading practical applications of the heating effect of electric power. I will not give you as answers, but you will remember it only as points. So the first thing that we should speak about is electric bulb. Points to remember. Electric bulb. Next bullet point you will write it as heading electric bulb. Okay, next bullet point you will write is energy conversion. Heading here. Next is energy conversion. Mention the energy conversion. Electrical energy converted into heat energy converted into light energy. Energy conversion.
Electrical energy converting.
Heat to light. Okay. Next point, next bullet point. Talk about material. Which material? Tungsten. High melting point. Right now, just words. That means to say these words should be there in your answer. Tungsten, high melting point. What is the melting point? 3380 degrees. Yes, 3380 degrees Celsius. Next, what did we say?
But does it heat up with heat?
It is. Immediately, the moment you switch it up, there is light. It doesn't even take a fraction of a second. Right? It's available. Okay. Next one. Inert.
Firstly, energy conversion, then the material use and melting point.
Yeah.
Then
3380 that you have written. Next one is inert atmosphere, inert gas or nitrogen to prevent oxidation. Is that okay?
to prevent oxidation.
To prevent oxidation of the tungsten filament. Why don't we put in air? Why should air be removed?
For
Oxidation. Okay, or to prevent oxidation. That is the answer. So these points you should utilize when you are writing down the answer. Okay. Leave a line and write down about fuse. Fuse. What is the principle? Based on circuit breakers, but based on what? Joule's law. Once again. Okay, based on fuse, the principle used is based on Joule's law of heat.
Principle.
Principle used is Joule's law of heat.
can I repeat the inert gas is nitrogen?
I think you're still stuck there.
Argon.
Nitrogen also.
Oxygen.
Raj, you better hurry up because the rest of them are all waiting for you. I cannot keep on asking them to wait for you. Okay. Next point, what will you write? What is this fuse wire made of? What is it made? No, see there. Alloy or a metal having low melting point. That is very important. For tungsten, you should have high melting point. Okay. But for fuse wire, you should have low melting point. Right. Material is aluminium, copper, iron, or an alloy which has got a low melting point.
This is aluminium.
Material which has got.
Yeah, it has to have a low value. See the last paragraph? Then there's a line in the middle of the paragraph which I want you to write. No, it's an edit. See, if a current larger than, please write down, if a current larger than the specified value,
Current is.
Larger than
keep your textbook open and please write down this, everyone. Did you get it? In the middle of the paragraph? Come on, write down. If a current larger than the specified value flows through the circuit, the temperature of the fuse wire increases.
so that
This melts the fuse wire and breaks the circuit. Okay, when you see the last paragraph, they are also talking about the rating of the fuse. Okay, what does it mean? Why should we use 1 amp or why should we use 10 amp or 8 amp? So that depends upon the appliance, right? And how do we actually calculate? Once again by using P in iron. If you read the last few lines here, for an electric iron which consumes 1 kilowatt, okay, electric power. So the moment you see electric kW, you know that it is nothing but power. Okay. When it is operated at 220 volts, so that's your voltage. Okay. Can you find out current? All of you do this now, quickly. I'm giving it to you in the form of a sum. Let's see whether it tallies with the answer there. This is for an electric iron. Okay. It's already given, operated at 220 volts. Which formula shall we use? P is given, V is given, I have to find out I.
P is equal to V, I am equal to P.
Very good, correct. So you have to find out I. So your formula is equal to P is equal to V into I is equal to P divided by V. So do this. Power 1 kilowatt. Convert it into watts. So you can write it as 1000 watts divided by volt is 220 volt. How much is that?
4.54.
What will the unit be? Current, we are finding out current. What is the power? The unit? Ayush, I don't expect you to talk. Everybody was silent till now.
4.54.
Oh, that's all. 4.54. Is that okay? Did you all understand? So if you are having 4.54 amperes which is flowing in the circuit, obviously you are going to require a 5 amp fuse. Okay? So nothing more should flow into the circuit. So that's why you are using a fuse wire based upon the quantity of current which is being drawn. Have you understood? Okay? put a Q there for the last paragraph. We can use it as a question. So they may give you some other appliance and ask what type of fuse wire is required. Did you understand it? Put a Q there and write what type of fuse wire is required or what is the power rating of the fuse. Let's look at example 11.12. Okay, cover that part because anyway we'll be discussing the answer. Try to understand what is given in the question. Your mathematical application is not being tested here at all because all the sums are very easy. What is important is how do we actually get the information and use the knowledge that we have. Okay. An electric bulb is connected to a 220 volt generator. The current is 0.50 amp. Did you see what I'm reading? From the
Yes.
book? It is from your book itself. Okay, what is the power of the bulb? Which formula will we use?
Equals
V,
to
and
V.
correct, very good. Please do it. Do it. What is important is we are going to pay attention to the units. What is given, what you have to find. Don't look at the answer, do it on your own. How much you find?
110.
Don't leave it at that. 110 and still 80. Will it be doing?
What?
What? After that. After.
It will not be Joule, just Joule per second. Joule per second is
Now
what?
we have attention.
That is it. What? See, P is equal to V times I. We are finding out I, which is equal to P divided by okay. Next one. Can we do the next one? Okay. Let's look at the next one. How to see the question?
A connected refrigerator rated 400 watts operates 8 hours per day. What is the cost of the energy to operate it for 30 days at ₹3 per kilowatt hour?
Kilowatt hour. Let's try to understand. Don't look at the answer. What is 400 W? Power. Very good. 8 hours in a day. Time. How many days?
30.
So what will you do? What will you do for?
14 to 8.
Yeah. So that will give you the total number of hours. So once we find out that, then you will use it
Units.
into converts. Yeah. Multiply, right? Units, right? 3 rupees. Okay. So for the next question.
Sorry,
What is this?
What?
It's 96,000.
96 kilo.
Wait, your joules.
What time?
Kilowatt.
Power, no? Power is what? Okay. So if you are having it as 96, what? 1,000?
Kilo. 96 watts.
Ah, 96,000 watt hour.
पर उसको बैठा दें।
But then you have to
What
convert
we are
it, no?
converting it to kilowatt.
This you convert it. Because for your unit, your 1 unit, I told you, is 1 kilowatt hour. Okay, so you want it in kilowatt. So you convert this itself, 400 watts divided by 1000 will give you in kilowatt. So it's more there. Okay, or even the answer that you have got it as 96,000. If you divide by 1000, it will come as 96 kilowatt hour. Okay. And next, what should we do? 1 unit is equal to 1 kilowatt hour. So you have got how many units? 96 units you have got. And what is the rate? Rate is how much? 3 rupees. So at the rate of 3 rupees per unit. Yeah, so then you multiply it to get your answer. Did you understand? Okay, look at the in-text questions there. Are you free? In-text first question.
What determines the rate at which energy is delivered by a panel?
Read the question again. Think carefully. What are they asking? Sometimes the words are very important. Otherwise, you may not get the answer. What determines the rate at which energy, rate of energy, the moment I talk energy upon time, rate, the word rate, that is the key word there, okay? The rate at which energy is delivered by the current. What is the rate of an appliance? Basically, we are talking of work upon time is nothing but one. So it is the power of the appliance. Okay, can we do the next one? Second one, do the second one. Electric motor takes 5 amps. What is 5 amp? Current. What is the symbol for current which alphabet we use? I. Current is I. Okay. 220 volt line. Determine the power of the motor. So which formula can you use? VI. Okay. And the energy consumed. First is find out power, then you have to find out the energy which is coming.
110 watt.
Like two,
So 220 to 5.
220.
110
Like 2 hours.
No, that is
तो
much
ऐसे
later.
तो निकाल के था.
That is later. Not 110. Check your zeros there.
1000.
1100.
So that will be
1100. Okay, 1100. What will be the
1.1 kilowatt.
kilowatt.
1100.
Watt.
1.1 kilowatt.
1 minute. So you got power as 110. Is it in kilowatt or is it in watt? Watt. Very good.
100.
Next part.
Then
Wait.
can we write 1.1 kilowatt?
200 joules energy.
Now energy consumed.
2200.
So what will you do? E is equal to what? Energy is equal to P to T. Power is If you are
100.
you use it as kilowatt and then use R. That is also correct. Okay. Next part of it is energy. You are going to find out, which is P times T. T you can convert it into kilowatt. If you are converting it into kilowatt, time should be in hour. Okay. Otherwise, you can keep it as it is. You can keep it in joules.
We can keep it normal.
Yes, either way also. Depends upon what they're asking you. Sometimes they specify how many units are expressed and depending on that you have to decide. Okay. Here I think they are asking you the answer here given in joules. So keep it as watts. Boys, look here. Instead of keeping it in kilowatt, you can keep it as watt and seconds. Convert the hours into seconds. Okay, so that will be joule seconds. Okay, right? Did you understand? So many joules you will get. So either this way, or you can keep it energy is equal to power. You can have it in watts, and time instead of keeping it in hours, you can keep it in seconds. Okay, and what is what? Nothing but joule per second. So your answer for energy will come in joule. Did you get it or no? Got it? The other way of doing it, do the other one also. Do this way also, you will understand. So how much is it? 1100 watt. Seconds is 60 times 60. How much is that? How many zeros? 1, 2, 3, 4. How much is that? Do this. Why did we do 60 to 60? 1 hour is 60 and plus there is a 2 hour also. Isn't it? They are given for 2 hours. 2 hours times minutes times seconds. How much is that answer? Do that. क्या हो गया?
कैंसिल हो गया
And I think you come for the next class now again. Hardly 5 minutes है.
Twenty minutes are there. 12:30.
How many? 1, 2, 3, 4.
अभी मैं डायरेक्ट से देख रहा हूँ
792
792.
4
Okay, 792, 10 raised to power of 4, that is correct. 4 zeros, correct.
7 into those 7.9.
So you can also write it as 792, 10 raised to power of 6. This will be in joule because you are talking about electrical energy. Boys, if you don't look, I'm going to rub it down. Just 5 seconds, whatever happens. Okay. The last part of the lesson here, what have you learned? Look at the bullet points. Unit of power, last 2 points, put a tick mark, this is what we have done today. The unit of power is what? 1 watt of power is consumed. 1 amp of current flows across a potential difference of 1 volt. How did we get that? Which formula are we using? Last but one point. Power is equal to 1 watt. Can you understand now? P is equal to V times I. Okay. The power of any appliance is 1 watt. If you have 1 amp current which is flowing through a potential difference of 1 volt. Did you understand? Take it down. Write down that statement and also take down this so you will understand. And write down the statement which is given in your textbook. The last one statement. Okay. Write down from this last but one statement. Did you write in your notebook? No. The last but one. The unit of power. We are talking about power. Write it down. The unit of power is watt. 1 watt of power is consumed when 1 ampere of current flows at a potential difference of 1 volt. Have you finished? Look at the next question. 2 lamps rated 100 watt at 220 volts, and the other one is 60 watt at 220 volts, are connected in parallel to an electric main supply. Okay, what current is drawn from the line if the supply voltage is 220? What is the information which is given to us?
Manhattan voltage of both the lamps.
Okay, good. Okay, sir.
They are connected parallel.
In parallel. So how will the diagram be? Yes. So the diagram basically is one bulb here, one bulb here. Okay, and this is your connection in parallel. So what is the rating of one bulb? This is 100 watt, and the other one is 60 watt. So these are the two bulbs. And what is the potential difference? V, how much is for V? It's given there, come on. We just see what is given in your textbook. 220. Voltage is already given to us, 220 volt. Okay, what are they asking you? Okay, what current is drawn from the line with the supply voltage is 220. It's obviously 220. So they're asking you how much current is coming from here. Look at the board now. What's happening in parallel? The current is coming from here. Some part of the current is going here, some part of the current is going here. Correct?
We have to find the R.
Yes. Find out current here, find out the current here, and then if you add it up, you will get a current here. So what is the current which is being supplied? This is what we have to find. So which formula shall we use to find out the current here? I. What is this 100 watt?
I is equal
What
to
is
P
this?
by V.
This is power, no? Right?
I is equal to P by V.
P is equal to VI, we have learned that. Isn't it? Power is given.
Now 5 by
V is
7
given. Find out I. I for this you find out. Find out I for this. Add it up.
Not for the first one, 0.4
Add it up. Find out for both of them. Did you understand what I'm saying? P, this is also power. This is also power. P is there. How do you know it is power? Because this W is there, no? The moment you look at W, you know it is in watt and it is power. So your formula will be P is equal to V into I is equal to P divided by V. Okay? Don't even work out your fraction, just keep it, don't even give it to me in decimal, just keep it as a fraction. So P is how much here? 100 watt. Voltage is 220. This is volt. Okay, so that will answer will be in ampere. This is for the first case. Second case, you find out the same thing. It is going to be how much? 60 watt divided by 220 volt. Okay, this is the again will be ampere. Add up these two.
Ma'am, I found a decimal also for the first one at 0.45 and for the second one at 0.27.
Okay, add it up. How much will you get?
Ma'am, that is going to be 8 by 11.
Okay, then do it. Do it. I want to see the working in your book. Don't do it in the last page. Okay? You can do this way also. You're more interested in what's happening here than what happened out there.
0.72.
Correct, very good.
Now we will be adding the decimal.
Yes. Again. What will be the unit? It's only apps.
On the first one, it is 0.45.
I said, don't even bother to give me a decimal. Okay, correct. If you have done it in decimal, how much should you get? 0.0. Okay, take care. 4, 5, please. Add up to
Toshida, first one,
5 by 11, 0.45.
Okay. So what is your final answer? 0.72. Okay, fine. So your answer will be current 0.72 ampere. Please make sure that you put the correct unit.
Toshida, you say that you will do
छाप रहे तो अपने आप समझ
No need to ask to complete. Okay, now the next one. Do the next one.
what will be the unit?
Current.
Ampere.
16.
Current, yeah, 16. I want everybody to do the,
चलेंगे उसका 0.5
0.0
11
five or eight. Okay, the next sum now, come on. Try to understand what is being given there. Which uses more energy? Now they have given you two appliances. Whose book is this? Whose textbook is this? I think it's very fashionable to come to the class without a textbook. Please go and sit in the first bench. Move. Hurry up.
10 raised to 5.
Watts, in watts, then you have to put it in seconds, or if you want to convert this to kilowatt. This is hour, this is in minute. So watt, second, better take seconds. You have converted it into seconds. Because one is in hour and the other one is in second. So make sure that you are converting everything. How much is the first one for TV?
9 to 10 power
4 or 5?
4.
Check out, check out. See,
Ma'am,
there's a 36 and 25. It's given in your, I don't know, this is an old one, last year's book. So the page numbers might be slightly different. This is on page number 137, but if you have to see. No, 30, see which page it is. No, it's another. No, it's last year's one. So this comes under, NCRT exercise. After that, NCRT exercise, it's here. So here.
Ma'am, for the second one is
How much you get?
7.2, 10 raised to 5.
Power of 5. So both of them is 10 raised to power of 5, so it becomes easy to start. So what's your final answer? 9 is more. So obviously, whatever is 9 is what TV said.
And 10.
Is there something coming up in your book now? Stop searching in your branch, don't search there. Question is here. It does so 15, 16.
15.
Is we have finished?
Yes.
Yes.
Yes, we have finished. Let's do this.
16.
You toaster, you toaster. ये टोस्टर का एक बराबर लिखो इसका वोल्ट ये टोस्टर के
What?
I see. Okay, now let's see how it has to be done. Boys, we are now doing question 16. Okay? We have two cases. One is a TV set and the other one is a toaster. Okay? Now 250 watt TV set and the time is 1 hour. So what are they asking? Which uses more energy? So what's your formula for energy? Energy is equal to what? P into T. Yes. So you have P, you have T, find out energy here. Similarly, P and T you have, find out which is what.
And T should be in seconds. Right?
Yes. This is in hour, this is in minute. Make sure that you are converting it into seconds. So this hour, it will be 60 times 60 seconds. Here it will be 10 minutes times 60 seconds. This is what you are going to use. Come on, do. Joule. Energy is in joule. Yes. 9.6 you got.
9 point, no, 9 into 10.
Okay. 9 you have got, is it? Ah, correct, okay.
And for the toaster, we got 7.2.
Okay. 6 or 5?
10
5.
raised to 6.
Is it 6 or 5?
6.
Ma'am, 5.
Ma'am,
What is the SI units?
You put a point there.
volume
So you have done the 17 part.
आज है volume वाला कैसे?
6 होगा 6.
No, wait.
There are 5 zeros. Should be 10 raised to 6.
There are 5 zeros.
Question pretty well.
How many zeros that raised to the power of 7?
Correct.
5 question pretty
हो गया 5?
5.
ये क्या 5 लिखा है?
अरे 5 और 4 बोल रहे थे
No.
मैं ठीक बोल रही हूँ कब से?
Varush, what's the confusion?
on there
If there are as many zeros, 10 raised to the power of as many zeros. Okay. Next one. Is it 17? Question number 17. An electric heater with a resistance
8
8 ohm is drawing.
15
So it's current. What alphabet?
15 square into 8
I. Current is I, remember. Okay. Time they have given 2 hours. Now to find
88 joules per second. Got it.
now this is where you have to be a little careful.
Power.
Rate
Power.
at which
Power.
heat.
Ma'am, we found out heat, that is 36
Yeah.
heat.
Whatever it is, heat divided by time. H is equal to I square RT. Whatever it is, that is your energy. Energy upon time, that is going to give you power.
फिर भी नहीं आ रहा।
Anish, you are supposed to go where?
Wedding, Pune.
Oh.
This wedding. Child marriage. Marriage. Stages are not very. अरे अनन्या बोलने का नहीं
किसका बॉटल हो गया?
हाँ नहीं वो यूट्यूब वाली ग्रुप खोलने वाला
अच्छा अच्छा
अबे तो है नहीं तेरा बॉटल।
किधर जा रही है?
आयुष्मान
किधर जा रही है?
ये ऑनलाइन
और ये देखिए